Do you remember being in high school and doing a certain kind of trigonometric proof that required you to move back and forth very intuitively and very gracefully between trigonometry thinking on the one side and then algebraic thinking, where you could do things like do substitutions and take square roots and such on the other side? So you might start off by thinking about the sine of an angle as the opposite over the hypotenuse, but then just a few mathematical steps later you're dealing with some sort of square root-ish substitution step. Okay. For some of us, that was so much fun. For the majority of human beings, it was so painful because it wasn't that they couldn't think trigonometrically in one moment and then algebraically. It was that, when do I flip back and forth deal? Now, if that was ever a problem in your life, and I don't know if it was, when you're trying to teach yourself the energy-based neural networks and you're trying to read the classic papers, that's why it is so difficult. There's multiple worldviews and kinds of thinking that are involved, and you're being asked to flip back and forth. And as an illustration, we're going to look at a classic paper. This is actually what I would regard as one of the most central papers in energy-based neural networks. This is the 2012 paper by Salakhutdinov and Hinton. Salakhutdinov was previously Hinton's graduate student. In the 2006 paper that they wrote together, they had the groundbreaking work of getting multi-layered Boltzmann machines to work together for image processing. So here we go. They're presenting a new learning algorithm for Boltzmann machines, many layers of hidden variables. So this is the multi-layer thing. And they talk about data-dependent statistics and a variational approach. Now look, I'm just going to skip through really fast and pull out some highlight terms to make a point. So here on page 1, we're talking about expectations and posterior distribution. Okay, cue the Bayesian logic. Posterior distribution means Bayesian, right there. Now, page 2. Page 2. There's a little history, okay? The early Hinton and Sejnowski paper, 1983, that invented the Boltzmann machine, very important. Then some Gibbs sampling in 1984, that's Gemin and Gemin, very important. A little bit of Markov chain stuff that came in shortly thereafter. I'm looking for that now. Well, that's Neal, 1992. So you've got persistent Markov chains due to Neal, 1992. So Gibbs sampling, Markov chains, those are their own thing. Then we get here, I am on page 3, back to sampling processes, Gibbs sampling, mean field, that's physics, probabilities, I'm looking for something very specific. Directed graphical models, that's another of its own things. Posterior distributions, again. Kullback-Leibler divergence. You need to know the Kullback-Leibler before you even start to read this paper. And somewhere in here it is, an additional data-independent term in the maximal likelihood gradient, and this term is the derivative of the log partition function. Log partition function. The partition function is pure hardcore statistical mechanics, so we are traversing so many different disciplines. That's why it's typically difficult for most people to come in here and just read the papers. So here's what we're going to do. The long pole on the tent, that's the statistical mechanics. That's where you figure out what a partition function is, so you can have the log of the partition function. Then, second most, I would say the Bayesian. And then we start filling in the blanks with things like Kullback-Leibler, Gibbs sampling, that is, Markov chains. And then we can start to bring them together, and it's a whole new level of thinking to say, okay, I'm going to shift from Bayesian to statistical mechanics and then over to Gibbs sampling, and then all this back and forth thing. That will build on a foundation that we need to establish first. So thank you for joining me. We're going to bring up more of these soon. We're working on a short course in statistical mechanics right now, and we're going to build out more videos that will help you with these interconnections. If you're finding this video useful, please do that like, subscribe, notify thing. And if you get over to the Themesis website, themesis.com/Themesis, we've got an opt-in, and you'll get a regular email whenever we put out blog, YouTube Short, anything that's relevant and interesting to you. I'm Dr. Aliana Moren with Themesis. Look for the associated blog post. I'll put a link in the description box below. Thanks for joining us. Have a great day. See you soon.